Hello everyone, welcome back to the another session in Principles of Programming Languages. Today we'll be going to talk about BNF grammar and Parse tree. This topic you'll find in first unit as the topic number 9. Now let's get started. So what is BNF grammar? We were already discussed few points about BNF grammar in the previous video, and the students who are watching this video, my sincere advice to watch the before video about BNF grammar. Now, so what is BNF grammar? This grammar used to describe the syntax, or else BNF uses abstractions for syntactic structures. So we'll take some example. I am taking a programming language of Java to define a assignment statement. So how I can write an assignment statement in Java? I'll follow this syntax. Assignment abstraction derives variable is equal to expression. Now, whatever I wrote in between of this angular brackets known to be abstraction, and the same is known as non-terminal. Abstraction or non-terminal means that the thing what has to be derived. Now it is an abstraction. Now it is derives. Variable is equal to expression. And in the definition of this assignment also you found again what you found, the abstraction. So abstraction has to get defined until it finds terminal symbols in the rule. Okay, this is what a general idea of BNF grammar. So in general, each rule in the BNF grammar will have left hand side, right hand side. Now left hand side, what we found, assignment abstraction. Right hand side is what, definition of this abstraction. So RHS side, right hand side, we probably having the definition part of left hand side. Now we'll see about how a BNF grammar is defined and what is the grammar. So basically BNF grammar is written in the form of rules. We'll write the rules. Rule is in terms of LHS and RHS, left hand side and right hand side. As I told in the previous slide, left hand side will be having a starting symbol of abstraction. RHS, it may have abstraction or it may have terminal. Okay, now we'll see about example. Now you can see describing a list in BNF grammar. Syntactic lists are described using recursion. Now look at this identifier list, which is defined in the abstraction, and identifier comma identifier list. The rule will calls itself. This is what recursion we were seeing in the earlier subjects, right? Now, so the purpose of the grammar is what? We have to derive the grammar, make sure that the sentences which are accepted by the grammar. Now, how I can get the sentential form from the grammar is I have to derive. What is a derivation? A derivation is a repeated application of rules starting with the start symbol and ending with a sentence. So this is what derivation. Basically this derivation happen to be two ways. One is leftmost derivation, rightmost derivation. So this video we'll see about leftmost and rightmost also. Fine. Now we'll take an example for a grammar for a small language. So every language will be having a common program, right? Every language will have some program. Now we'll take the syntax to define the program. Program derives. It derives begin and end. In between we'll write a statements. So now I am defining the statement list as an abstraction. So it has to get derived again. Now write about the rule. What statement list should consist? Statement list should derive a single statement. Statement list can derive a single statement, or else it can divide the recursion process, the same statement list. Now statement has to get again derive. Now statement derives variable is equal to expression. Now variable is equal to A or B or C. Expression is equal to variable plus variable or variable minus variable or else variable. So this is what a grammar for a small language. So as soon as we found the grammar, what we have to do is we have to find out the derivation of the grammar. Now how to derive? We have to apply repeated application of the rules in the same grammar to find the sentential form. So what I am going to do is I am going to derive this. How to derive? You have to consider the first starting symbol of the rule. So you have to take this. Now let's start the derivation part. I told you that in the previous slide the derivation can be possible leftmost derivation, rightmost derivation. We'll see the both in this example. Now the derivation is what? We'll derive it by taking the first step of the rule. Program derives begin, statement, list, end. This is what the first rule of the grammar. We did not find terminal symbols to stop it. When derivation can stop? When you found terminals. But I did not have terminals. I have still non-terminal. That means abstraction. Again define it. Statement list can be defined. That means statement list is derives single statement. The single statement can be derived variable is equal to expression. Now variable can be derived by substituting the first alphabet or first token, which is A. Now this expression can be written as variable plus variable. Now so pause a second here. You have two things after in the definition of this A. That means this is what left hand side. This is what right hand side. When you look at these two, you are finding this at left hand side, you are finding this at right hand side. Now the derivation part always will be for this side. If I start deriving this, I should call this as leftmost derivation. Now the solution of leftmost derivation is what? A is equal to, I will be replacing this abstraction, that is variable. It can be written as B plus and this variable. So if it is a rightmost derivation, then it will be what? A is equal to, this variable will be as it is, this variable will be get substituted with B. Now leftmost derivation B plus C, rightmost derivation C plus B. Did you understand? So a grammar can get derived using leftmost or using rightmost. So this is the way of doing leftmost and rightmost. Finally we'll get the answer something like this. Now so we'll see about a grammar for simple assignment statement, that is assign derives id is equal to expression. id derives A or B or C. Expression derives id plus expression or else id into expression or parenthesis expression and id. Now this is one grammar for simple assignment statement. Now if you keen observe this grammar is little bit different from the existing grammar. What grammar we were seeing in the earlier leftmost rightmost derivation, that is different, this is different because we were added this term newly, correct? Now let's see how this will get derived. So I am using leftmost derivation here. Now the sentential form is what? We'll be having a question whether this sentence is accepted by the above grammar. Now I have to derive to check. The derivation of the grammar is, I am doing at leftmost derivation. So assign derives id is equal to expression. Now id is replaced with a, token a. A is equal to expression. Now a is equal to expression can be written as id into expression, and this id can be written as b into this expression can be replaced with expression. Third rule, expression. Now b into this expression can be written as id plus expression. Now b into id is what? A. Expression is written as id. B into a plus c. Now we got terminals at the end of the line. So this is what the final derivation of the above grammar or above sentential form. Now talk about parse tree. Parse tree is what? It is an hierarchical structure to construct the syntactical sentential form of the grammar. It's a hierarchical structure. Now, when you can generate two or more distinct parse trees, then it is called as ambiguous grammar. A grammar is said to be ambiguous if it can generate two or more distinct parse trees. Unambiguous means we'll have only one parse tree for one sentential form. Now look at this. There is a grammar and we have to check whether it is ambiguous or unambiguous. So it is what expected question in the examination point of view. So we were taken a grammar over here, correct? The grammar is what? Again, let's see the grammar. This is your grammar. Now the grammar is program statements, statement, variable is equal to expression. Now let's write the parse tree for this grammar. So how I can draw a parse tree for this? Assign we'll take in the next thing that I'll draw a parse tree for the simple assignment statement. A is equal to b into a plus c. Assign id is equal to expression. Okay, it is a id into expression, and this id is what? B. This expression is written as again id plus expression. Okay, this id is a, this is what id, and c. So this is what the parse tree for this sentential form. So next video we'll be going to talk about ambiguous and unambiguous grammar. Thank you all.